Kia ora, Ben, Snehal and Tausif, and anyone from 12MCA who's watching. So I'm going to start making you some videos again now that the level 3 trig is just about finished. The first one that I'm going to do goes with exercise 7B in the stats textbook. And this is one that is a really cool skill to have down really well. This comes up all the time in the stats papers, and it's quite tricky until you see how it goes. And it's called the normal approximation to the binomial. So what I'm going to do in this video is basically go through an exam problem and do a little bit of teaching along the way. So the first thing we need to understand is why would we want to do this, and then how would we do it? And to look at that, I'm going to go straight into this question. So we've got a survey of adults in a certain large town that found that 76% of people wore a watch on their left wrist, 15% wore a watch on their right wrist, and 9% did not wear a watch. So the first question is one where we're told that a random sample of 14 adults was taken, and we had to find the probability that more than 2 adults did not wear a watch. So hopefully you can see that with a tiny bit of work, we can turn this into a very simple binomial question. For a binomial, we need to have 2 outcomes. So in here it's, did they wear a watch or did they not wear a watch? The number of people is 14, so that's my fixed number of trials. And the probability that they don't wear a watch is 0.09. So on any one trial, this is the probability that they don't wear a watch. And I'm going to write down x as the random variable, so the count of the number who don't wear a watch. And we've done the binomial stuff pretty thoroughly back in chapter 6, so this should feel pretty easy. So the number who don't wear a watch is what we're trying to find. The probability that they don't wear a watch. And we want the probability that that number is greater than 2, and that's the same as 1 minus the probability that x is less than or equal to 2. So I need to work out the probability that x equals 0, probability that x equals 1, and the probability that x equals 2, and then I'm going to add those up and take them away from 1. So the first one, the probability that x equals 0, will be 1 times 1 times 0.91 to the power of 14, which gives me 0.267042. Right, the probability that x is equal to 1 is 14, so that's my 14 choose 1 number. So 14 ways to get 1 times 0.91 to the power of 13 times 0.09 to the power of 1. That gives me 0.36975. Now, if this is going too fast, you need to go back and find some of my binomial videos that will either be on the level 3 stats playlist or else on the AS one. And for the probability that x is equal to 2, it's going to be 14 choose 2 times 0.91 to the power of 12 times 0.09 to the power of 2, right? So these are the 2 people who aren't wearing a watch, and that works out to be 0.2377. So the probability that x is greater than 2 is just 1 minus all of those. Don't run too hard here. And it's fine to do that in your calculator, but you do need to show quite a bit of working. So here we get 0.1255. Okay, so that should all feel pretty good. Now, where this normal approximation to the binomial comes in is when we get a question like the next one. This time, we're told that we've got a random sample of 200 adults and find the probability that more than 155 wore a watch on their left wrist. So let's just think about why that actually is a binomial problem, first of all. Well, we've got a fixed number of trials, right? We've got n is equal to 200, and we can figure out the probability that any one of them wore a watch on their left wrist. So we're going to have y equals number wearing watch on left wrist. Don't have to write that out, but it often helps us set the problem up. And the probability of that happening is 0.76, and 1 minus the probability of that happening is q, which is 0.24. Okay, so we can do a binomial calculation on that, except that it's going to be incredibly painful, because if we want the probability of more than 155 people, we've got a lot of adding up to do. Right, so we've got to add up probably there were 156, 157, and so on. It was bad enough doing it for 3. So let's look instead at what we can do for an approximation. Well, we can see in here that the mean of the binomial, so E of x, mean of the binomial is NP, so 200 times 0.76 gives me 152. And the variance of the binomial, oh, actually, I think I've said y, not x, so the variance of y is equal to NPQ, and that works out to be 36.48, right? So timesing these three things together. So we know the mean and the variance, and we can see that these numbers are, they're not in the middle, they're not at 0.5, but they're not crazy, crazy tiny numbers. So if we draw, we can draw a bar graph to represent y, and the bar graph will have the average at 152. And if you do this in GeoGebra, and I haven't had time to do this morning for this video, you'll see that you get a roughly normally distributed bar graph. And strictly speaking, you could think of that graph as it's in the textbook with separate lines, right? So bad drawing, oh, very bad drawing, hang on. So you could think of having a line at 152, that's the mean, right? Then you have a little line here, and a little line here, and a little line here. But what we're going to do is we're going to use the normal distribution to approximate this discrete distribution. So if you think about sitting the normal curve on top of this, then the way we're going to solve this problem is we're going to do a little bit of an adjustment, right? We're going to use the normal distribution, and for that we need to have a mu and a sigma squared. And they are pretty easy to see what we should use. The mean is going to be 152, and the variance is going to be my binomial variance, which is 36.48. So my standard deviation will be, obviously, the square root of that. So that's all good. So we might think that we're going to find the probability that y is greater than, what do we want? Y is greater than 155. But this is where we need to make a little adjustment. If you think about y as being the bar chart, we can now think about y dash as being the normal approximation, right? So y dash is what we do when we're doing this approximation with a mean of 152 and a variance of 36.48. So that's sigma squared. Let's think about it now as, instead of a line graph, think about each value as being a bar. So that bar at 152 goes like that. And the bar at 153 goes like this. So we want to have greater than 155 people who are, what are they doing? Wearing watches or something. So when we draw that bit of the bar curve out, here's 152, this is 153, and so on. We don't want the 155th bar in there. So we don't want to be colouring that one in. We want to start our colouring in from here. And if you think about it like that, you're always going to get this idea of a continuity correction done right. Think of that 155 as extending back to 154.5 and going up to the edge of the bar that we do want in here. That means that instead of doing something with 155, we have to do this little adjustment, right? Because we're going to get not quite exactly what we want. And instead of finding something with 155, we're going to find the probability that y dash is greater than 155.5, right? Because we want to include the 156th value. So we go back to there. And from here, it's pretty plain sailing. We get the Z thing works just as it usually does. So we standardize. We go 155.5 minus the mean divided by the standard deviation. So this part of the question should feel really good. I bet you're switching off the video. Just watch to the end. Okay. That gives me the probability that Z is greater than 0.579. And so sketching that, we want this bit out here, which means we want 1 minus phi of 0.579. Hopping over to my normal table, I've got 0.57 here, and I need to add on the 9, right? So it's going to be this plus this. Where's it gone? Okay, so that's going to be 1 minus 0.7157 plus 0.0031, and that gives me my final answer of 0.281 to 3 significance figures. So there you go. These problems, they're a bit funny until you get used to them, but I found over the years that if you draw that bar chart and you look carefully at the adjustment you have to do to your end value, then you probably won't go wrong. So lots of practice on these. This one is actually in exercise 7B, and I think it's question 8. But because it's an exam question, I didn't feel too bad about just taking it straight from the textbook. So email me if you've got more questions on that exercise, and I'll try and get some work solutions up for you over the next few days. Thanks for watching.